Hi, welcome to my video on the system of linear equations, two variables, solved by the elimination method, part 2. Solving by the elimination method. Let's continue. As you can see, I'll do one step at a time in the solving the system, and then we'll put it all together at the end. Solve by elimination. Step 1 was write both equations as ax plus by equals c. Step 2 is going to be the next step we're going to encounter. But before I do that, let me explain with a little bit of background on what we're trying to do. Multiply 2x plus y equals negative 5 by 4. So if you multiply 4 times 2x plus y equals negative 5 by 4, you will get 4 times 2 is 8x. 4 times y is 4y, and 4 times negative 5 is negative 20. So notice you're multiplying every term in the equation, every expression or term by 4. So 4 times each one. And also, we're going to multiply every term in the equation by 3. So 3 times 2x is negative 6x. 3 times 1 is negative 3y. 3 times negative 5 is 15. So what happens, we come up with a new equation that's being represented by this one. So these two equations are, all of these equations here are the same in a sense. What? If we take this equation and solve it for y, we solve this equation for y, and we solve this equation for y, and write it as y equals mx plus b, all three of these equations will have the same y equals mx plus b form, even though the equations look like they're different, but they'll have the same y equals mx plus b form. And just to illustrate that, well, I'll do it down the bottom here when I'm finished. Let's take this equation, multiply negative 3x plus 4y equals 2 by 5. So I'm going 5 times this equation. So we multiply by 5. 5 times negative 3x is negative 15x. 5 times 4y is 20y. 5 times 2 is 10. And we multiply the equation by negative 2. So write it down. Notice I write it down to not only, to show you, but to make sure I don't make an error. I could take this equation right here and multiply by 5 in my head and go negative 15x plus 20y equals 10 without writing this. But writing it down, the tendency is not to make an error. So negative 2 times negative 3 is 6x. Negative 2 times 4y is negative 8y. And a negative 2 times 2 is negative 4. So writing it down, you have a tendency not to make an error. Now let's illustrate what I was just talking about and to show you what I mean. 2 comma 3 is a solution to this equation. Let's illustrate that. How do I know? Well, x is 2 and y is 3. So 4, if I put 2 in the place of x and 3 in the place of y and work it out, I multiply, I get 8 before I add. So I get 11 equals 11. So that verifies that this point, the values of x and y make this equation true. That means that that point lies on this line. So let's take this same equation and multiply it by negative 5. So that's the equation there, same as this one. So if I multiply it by negative 5, so write it down. So here I go. Negative 5 times 4, x, negative 20x. Negative 5 times y, negative 5y. Negative 5 times 11 is a negative 55. So this new equation is the same as this one in that they represent the same line if I graph them. But let's see if 2, 3 is a solution. 2, 3 is a solution of this because it worked out. let's see if there's a solution of this one. So x is 2, y is 3. We sub it in. We multiply PEMDAS. There's no brackets to simplify because it's 2 and 3, no powers. We multiply before we subtract. So negative 20 times 2 is negative 40. Negative 5 times 3 is negative 15. So negative 55 equals negative 55. True? So multiplying the equation, all the terms by the same number, still represents the same line, even though this equation is different than the new one here. They still represent the same line. And let's illustrate that. Just watch. If you take 4x plus y equals 11, and you take the new equation, which is 20x minus 5y equals negative 55, solve this for y, and I get y equals negative 4x plus 1. If I solve this equation for y, negative 5y equals 20x minus 55, divide by negative 5. And just to go back, remember I'm solving it for what form? Y equals mx plus b. Y equals mx plus b. I'm solving this one for y equals mx plus b, so the minus 20 moves to the right side to become plus. And we divide by negative 5, divided by negative 5 is a 1. 20 divided by negative 5 is negative 4x. And negative 55 divided by negative 5 is a, see? There's 11. And I just noticed, I wrote it down now, and that's 11 there. Because over here I got plus 55 divided by 5 is 11. So when I rewrote this one, I left off my 1 right there. Normally, I have to be careful. I make mistakes, but I normally correct myself by looking back. So notice these two equations look different, but when I solve the equations for y, they become the same line because the two have the same slopes and y-intercepts are the same. So these two equations represent this line. Whatever point that satisfies this equation will also satisfy this equation. Let's continue. Now we're going on to step 2. We're ready for step 2. Step 2. The coefficients of one of the variables have to be opposites. One of the variables has to have opposite coefficients. Example, this one got a 3x, this one's a negative 3x. So the x's are the opposites. Only you could have one of them or two of them, but right now we concentrate just on one of them. So they are the opposites. Notice over here, this is a negative 5 and 2, they're not opposites, but negative 6 and plus 6, the y coefficients are opposites. So let's do a bit of practice. Write each so that the coefficients of one of the variables are the opposites. Let's look at this one. I have 2 and 2, they're not opposites. 5 and negative 5. So we don't have to do anything, they're already opposites. Right here, B, I have two equations, they're in A, this is ax plus by equals c form, perfect. These are opposites, so this is already done. That's a 1 and a 2, they're not opposites. Now, they're in the right form. Notice we got ax plus by equals c, ax plus by equals c, they're the right form, perfect. So we practice in the first video on elimination, but we want one of these. Now you notice, some of you might be saying, sure, the two of these systems are the same. Yes, I deliberately put the two of these down the same. Why? Because if that's a 2, I want this to be a negative 2. So what I'm going to do with this equation, watch, I'm going to put a negative 2 right there. In other words, I'm multiplying this equation by negative 2. That gives me negative 2x minus 6y equals negative 8. Negative 2 times x, negative 2 times 3, negative 2 times 8. Now if I write down the second one, now I could multiply this one by 1, but multiplying by 1 is not going to change it. So what do I have now? I have the x is the opposite of each other. So I have one of the variables with opposite coefficients, which is what I want. But somebody might say, well, why don't you multiply the second one? That's a 3. What do you want here? I want a -3. So that means I can multiply, if I want, I can multiply this equation by 3. And if you multiply this equation by 1, it's not going to change it. So 1 times that equation is x plus 3y equals 4. Multiplying it by 3 gives me 3 times 2 is 6. 3 times -1, -3y. And 3 times 1 is 3. Notice now, the y's are the opposite of each other, but you only need one of these. You don't have to do both. You only need one of them so that the one variable has one pair opposites, one of the variables. So you could do this one, or you could do this one, your choice. But this one is better because you're multiplying by 3. 3 is positive. This one is nothing wrong, but you're multiplying by a negative, so you gotta be careful. It's better to multiply by a positive number. You won't make an error, but it's your choice. D. Notice D now. I have the same equation 3 times. That means I have lots of options. So do I want the best one? Just watch. If you look at this one, the easiest one to do, if that's a 1, so if that's a 5, I want this to be a -5. So I'm going to multiply this one by 5. So the first equation, again, I put it here, but we don't need it. We multiply by 1, so we get 2x plus 5y equals 1. That's a 5. I don't have to change it. Now I'm going to multiply this equation by 5. 5 times 3 is 15. 5 times -y is -5y. And 5 times -2 is -10. So I have the y's the opposite of each other. Perfect. But there's also other options. And another option is that if I want to get rid of the x's, I could multiply this one by 3 and this one by -2. Notice they're both even. Sorry, both positive. So I have to have one of these numbers negative to get an opposite. So if I multiply by 3, I'll get 6x plus 15y equals 3. 3 times 2, 3 times 5, 3 times 1. -2 gives me -6x plus 2y equals 4. So if I want to eliminate the x's, I would multiply by 3 and a -2. And I get the x's the opposite, not the y's. And somebody else says, well, why don't you multiply this one by -3 and this one by 2? -3 times 2 is -6. 2 times 3 is 6. So that gives me opposites. So -3 times all of these is -6x minus 15y, -3. So -3 is multiplied by all these terms. There they are. And now I'm going to multiply 2 by all of these. 6x minus 2y equals -4. And so if somebody could multiply by 3 and -2, somebody else could multiply by -3 and 2 here. But you still get the x is the opposite, but different equations. But that don't make, so any scenario, you can do what you wish as long as you have the coefficients the opposite. But again, the easier choice is to multiply this by 5 because that's a 5. You want a -5 here, so 5 will do it. But when you do the x's, you got to go 3 and 2 or 2 and 3 plus or minus. So just showing you different options. And the last page is practice. Practice means do one at a time, pause the video and work out the answers. And what you might do is what I might do, you might not do. But as long as you get in the opposites, change each equation so that the coefficients of one of the variables are opposites. Now, notice we didn't have to change this. Why? Because they're already opposites. So if they're opposites, don't touch them. Just leave them alone. You don't want to make the y's the opposite because the x's are already opposites. So leave it alone. And number 2, we have which one? Notice they're here twice. So if I want, that's a negative 8, I multiply this one by 8. Why? Because 8 times x. So the first equation is 8x plus y equals negative 3. The second one, 8 times x is 8x. 8 times 9, 72. 8 times 5, 40. So I have the x is the opposite of each other. Or somebody else might multiply this one by, that's a 9. They might say, I'm going to do a negative 9. So they go bracket, negative 9. And again, this is understood. I'm not changing this, so that's a 1 times that. So negative 9 times negative 8 is 8 nines are 72x minus 9y equals 3 nines are 27. Negative and negative is positive, and you don't change the first one at all. You're just leaving it alone, multiplying by 1. 1 times this stays the same. Notice now the y's are the opposites. But again, it's your choice. You can have the x is the opposite or the y is the opposites. Number 3. Again, I have this equation down twice. So which ones do you want to change? Somebody might say, I want the x's to be the opposites because that's plus and that's a minus. I don't have to, because they're opposite signs right now. I only got to multiply this one by 5 and this one by 4. That will give me the opposite of the x's because they're already plus minus. So 5 times 4 is 20x. 5 times 3 is 15. Y. 5 times 0 is 0. 4 times this equation is a negative 20x. 4 times 2y is 8y. And 4 times 0 is 0. So I have the x is the opposite. But if you want to make the y's the opposite, well, here's what happens. The y's are the same sign. So you can make this a negative 2 and make this a 3. One of these numbers has to be negative. So it could be negative 2 plus 3, or it could be plus 2 minus 3. So negative 2 times 4 is negative 8x. Negative 2 times 3 is negative 6y. And negative 2 times 0 is 0. 3 times negative 5, negative 15x. And 3 times 2 is 6y equals 0. So the first one I did x's, the second one I did the y's. So hopefully you're seeing what's happening. And number 4, again, is here twice. So which pair do you want to pick? Which is the better pair? Well, the better one that I would pick is this one, because they're already plus minus. So if you want, you could multiply. Oops, I got the bracket gone right down. Let's just put it right there. If I want to do a 3 and a 1, if I do a 3 and a 1, the y's will be the opposite. So it's 12x plus 15y equals 6, 3 times all the terms. And 1 doesn't change it. But notice I have the y is the opposite. Perfect. Or you might want to make the x is the opposite. But if you make the x is the opposite, that's a 4. You need what? Minus 4. So you multiply this one by negative 2. And you multiply this one by 1. So 1 times it gives me 1 times 4x, 1 times 5y, 1 times 2 is 2. Now multiply by negative 2, I get negative 4x plus 30y. Negative 2 times negative 6 is 12. Now the x's are the opposites, so it's your choice. It's your choice when you're solving equations how you want to do them. Nobody can tell you what to do. And the last one, number 5, again, I have it written down twice. If I were doing this one, I see a 7 and I see a 1, I would multiply this one by -7. And just to put that there, I will multiply that one by 1, but I don't have to. So 1 times -3x, 1 times 7y, 1 times 4. Now I multiply every term by -7. 35x minus 7y equals 28. And because that's a 7, I want a 7 here in negative. I multiply all the terms by -7. And I only multiply by one number. But if you want to eliminate the x's, that means you got to multiply, first of all, that one by 5 and that one by 3. But because they're the same signs, one of these numbers got to be a negative. So let's make the 5 negative and 3 positive. Now multiply. 15x minus 35y equals -20. So I multiply -5 by all of these. There they are. Now I'm going to multiply 3 by all of these. -15x plus 3y, -12. And notice now the x's are the opposite. But the easier one was to multiply this one by just a -7 to get the opposite of 7, because that's a 1. Anytime you got a 1 coefficient, it's easy to do. But when you don't, you got to multiply by 5 and 3, or like up here you had to go 2 and 3 to get opposites. 3 and 2, 2 and 3. And that leads us to explaining the second step in solving a system of eliminations. And if you enjoyed my video, click the like button, subscribe button, and notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel. Thank you very much for viewing my video. Hopefully it was helpful. Bye-bye.